Welcome to Mewi Science channel. Today we're looking at hydrocarbons, but we're concentrating on the alkanes. Remember, in Mewi Science, what we do is that we simplify organic chemistry. So if you're able to follow episodes one after the other, believe you me that you understand organic chemistry to its simplest level. So today we'll be discussing about hydrocarbon, and then we'll be focusing on the alkanes. What's hydrocarbon? A hydrocarbon is a compound composed of only carbon and hydrogen. So like the name, hydrocarbon. Hydro there stands for what? Hydrogen. While the carbon there stands for what? Our normal carbon. So hydrocarbon is a compound that has only what? Carbon and what? Oxygen. Carbon and what? Hydrogen. Carbon and hydrogen. That is for the hydrocarbon. Okay. The hydrocarbon is subdivided into the saturated hydrocarbon and the what? Unsaturated hydrocarbon. These are the two main branches of hydrocarbon. When we talk about the saturated hydrocarbon, we are actually talking about hydrocarbon that has carbon-carbon single bond. So in their bond formation, you see only what? Single bond. While the unsaturated hydrocarbon, we have more than what? One bond. It could be double bond, it could be what? Triple bond, it could be benzene ring. Those ones are the what? Unsaturated what? Hydrocarbon. Under saturated hydrocarbon, we have the alkanes. So an alkane is a saturated hydrocarbon. That is, they contain carbon-carbon what? Single bond. Whenever you see a hydrocarbon that has carbon-carbon single bond, then you know that it is an alkane. And then under unsaturated hydrocarbon, we have the alkenes. Alkenes, they have one or more carbon-carbon double bonds. In a particular structure, which is an alkene, you may see one double bond, you may see two double bonds, 3, 4, and so on. So when you see a double bond, then you know that it is what? An alkanes. We also have the alkynes. The alkynes, they have carbon-carbon what? Triple bonds. While the arynes, these are the benzene ring. The benzene, we talk about aromatic hydrocarbon. So we now know that saturated hydrocarbons, they are those hydrocarbons that contain what? Carbon-carbon what? Single bond. And the basic saturated hydrocarbon is what we would be discussing today, which is the alkane. Alkane has a general formula, which is CnH2n plus 2. So this formula is the general formula for all alkanes. N here could be 1, it could be 2, down to infinity. It is an integer. So let's assume n is 1. Suppose we have n equal to 1. If n is 1, in place of n, you put what? 1. Anywhere you see n, you put 1. So we have C, 1. We're doing our hydrogen, 2. In place of n, you put what? 1 plus 2. If you do this simple mathematics, you will get this. C1 is the same thing as what? As C. We have our what? Our hydrogen. 2 multiplied by 1 is 2, plus 2 gives what? 4. So this is how we get what? Our alkane, using our general formula CnH2n plus 2. Now this is the simplest alkane. Do you know why? Because we are starting from what? 1. 1 is the simplest number, right? So this is the simplest alkane, and this alkane is called methyl. This alkane is called methyl. If you want to go on, you can still get the second alkane by making n what? 2. So if n is 2, we are going to replace 2 with what? N in the equation. So we have C2, hydrogen, you put our 2, in place of n, you put what? 2 plus 2. At the end of the day, we'll get C2. This is C2. 2 times 2 is what? 4. Plus 2 gives 6. We have 6 what? Hydrogen. This is the second what? Alkane. And what is the name of this alkane? Guess what? The name is what? Ethyl. So this is the general formula for alkane. With this formula, you can get all what? Alkane. Why we call this the molecular what? Formula. Let's put it MF, the molecular what? Formula. So if n is 3, you can get for 3 down to any number you want to find. Alright, we have what we call condensed structure. We also have what we call the Kekulé structure. And we have the skeletal structure. Let's get the condensed structure of this. The condensed structure of ethyl. We have how many carbons here? There are 2 carbons here. So for you to write down the condensed structure of ethyl, you first of all bring out your 2 carbons this way. We have carbon 1 and what? Carbon 2. In organic chemistry, carbon is always tetrahedrally what? Bonded. Therefore, since we have what? 6 hydrogen here, it means the first carbon will carry 3 hydrogen, while the last carbon will carry what? 3 hydrogen. So basically, you have to know this in organic chemistry or when it comes to alkane. When you are writing or drawing the condensed structure of an alkane, the first carbon, you add 3 hydrogen to the first carbon, and then you also add 3 hydrogen to the what? Last carbon. So let's do it that way. We have 3 hydrogen, and we have what? 3 hydrogen. So this is the condensed structure or condensed formula of what? Ethyl. This is condensed structure of ethyl. From here, we can also get what we call the Kekulé structure. In the Kekulé structure, the electrons are shown as line, but the lone pairs are not given to us. We eliminate the lone pairs in the Kekulé structure. So the Kekulé structure is like an open structure where you see how the hydrogens surround carbon or how carbons are being tetrahedrally bonded. Let's learn how to draw the Kekulé structure. Let's start with the first carbon. This is the first carbon. The first carbon has what? 3 hydrogen. That's 3 hydrogen. So put our 3 hydrogen, hydrogen 1, hydrogen 2, and hydrogen what? 3. Okay. Let's go to the second carbon. The second carbon also has what? 3 hydrogen. Hydrogen 1, hydrogen 2, and what? Hydrogen 3. Wow. So this is what? Open structure, or you call it the Kekulé structure of ethyl. Very simple. We also have what we call the skeletal structure, or the line angle structure in form of line. In the line angle structure, each point indicates what? Carbon. So this has 2 carbon. We have something like this. So in the line angle structure, or let's take it this way. Let's take it this way. This is the line angle structure. This point here has a carbon, and this point here has what? Carbon. And that, let me use a red marker for that. So we have carbon here, and we also have what? Carbon here. So how many carbon do we have here? We have carbon 1 and carbon what? 2. This is what we call the line angle structure. Carbon 1 and carbon 2. So if you see this, know that you are talking about ethyl. This is ethyl, this is ethyl, this is ethyl, and this is also what? Ethyl. Alright. Alright, since we've known the first alkane, we've also known the second alkane, let's move over toward the third alkane. If we use the same formula, H2N plus 2, we are going to end up getting all the other alkanes. We have the propane, which is for 3 carbon. We have butane for 4 carbon. We have pentane for 5 carbon. We have hexane, 6 carbons. We have heptane, 7 carbons. We have octane, 8 carbon. We have nonane, 9 carbon. And then nonanes, we have decanes for 10 carbon, and the rest. You can keep on naming them. So, but for these 10 alkanes, I think it's very, very important at your level to know all these 10 alkanes. We are going to use them in our nomenclature when we come to nomenclature of alkane. So when we have 3 carbon, we call it propane. 4 carbon, we call it butane. 5 carbons, we call it pentane. We have the hexanes for 6 carbon. We have the heptanes for 7 carbons. Hope you are following. We have the octanes for 8 carbons, the nonanes for 9 carbons, and then we have the decanes for 10 carbons. Alright. We can, in our spare time, learn how to use the formula to get all these. Okay. Before we look at how to name alkane, we have to know what we call alkyl group. Remember I said alkane has this formula CnH2n plus 2. That's for alkane. For example, we have our methane, the simplest alkane. In alkyl group, or we call it the alkyl group, in alkyl group, we are removing one hydrogen from an alkane. So when you subtract one hydrogen from an alkane, you get the alkyl group. For example, if we have CH4, 4CH4, yeah, methane. If we have methane and then you remove one hydrogen from methane, we'll be left with CH and 3. This CH3 is the methyl group. An example of the alkyl group. We have to know this in our head because this is a substituent. It will help us when we start learning how to name organic compounds. Alright, these are the basic rules we should all know. It should be on our fingertips so that we can be able to name organic compounds. If you don't know all these rules, it will affect you in naming organic compounds. There's no need of you memorizing these rules. No, we don't do that. You understand. With practice, you understand these rules and you know them. You don't need to memorize them. With time, and then when you read them and keep on learning how to name or draw new structures, it will be part of you. So this is how we do it. We'll take it one after the other. Nomenclature of alkanes. These are the rules. There's what we call IUPAC. IUPAC stands for International Union of Pure and Applied Chemistry. The International Union of Pure and Applied Chemistry came together to give procedures and rules that will be followed for a compound to be named. Why? So that there will be a generalized name for each compound all around the world. So that is why the IUPAC, called the IUPAC, came up. International Union of Pure and Applied Chemistry. These are the rules. Number 1 is Before you name an alkane, the first thing that you pick your mind is identifying the longest chain. You first of all identify the longest chain. Then the next thing is give each substituent on the parent chain a name and number. Remember, I talked about the alkyl group, alkyl group. The alkyl group is known as the substituent in most instances. Another thing you have to know is number the parent chain in the direction that gives the substituent the lowest number. Don't worry yourself about memorizing all these things or understanding it now. When we start naming different hydrocarbons, then you know how to apply all these rules. Substituents are listed in alphabetical order. Prefixes like di, tri, tetra are not included in alphabetical order too. Then choose the parent chain with the greater number of substituents. Alright, I know you're already like, how will I get to know all of these? How will I memorize all of this? Don't worry yourself. By the time we start naming this compound here, then you know how to apply these rules. And definitely you know them without even memorizing them. Alright, let's name this first compound here. The first hydrocarbon there. Alright. The first rule says we should do what? We should identify the longest chain. That should be the first thing that will prick your mind. You should always remember, identify the longest chain. Alright. What's the longest chain here? I'm going to use our red marker. We have in this structure, you can either number it this way, right hand side, or you number it this way, the left hand side. So if you number it this way, 1, 2, 3, and 4. We are having 4 carbons. If we number it this way, it will be the same thing, 4 carbons. Apart from that, there is another way we can still number this. Of course, there's another way. There's another way we can still number this. You can number it this way, 1, 2, 3, 4. Okay, it's the same. So we've now known that no matter the angle you are coming from, it will give you the same number of carbons. Alright. Give each substituent on the parent chain a name and a number. This is the substituent now. The methyl. An example of an alkyl. The methyl. This is the methyl. Let's go to rule 3. Number the parent chain in the direction that gives the substituent the lowest number. Alright, we've been able to identify the longest chain as butane. As butane, because butane has 4 carbons. We've been able to identify the substituent also. Now we are going to number the parent chain in the direction that will give these substituents we are seeing here the lowest number. Therefore, if you number this way, 1, 2, 3, and 4. Let's see. Numbering it this way on the right hand side. Our substituent, the methyl group, will be on carbon 3. Carbon 3. That's carbon 3. Carbon 3. Okay. How about on the left hand side? We have 1, 2, 3, and 4. So if you number it this way, our methyl group will be on carbon 2. Carbon 2. Carbon 2. Sorry. Carbon 2. But the rule says that we should number the parent chain in the direction that will give the substituent the lowest number. And that is what we are going to do here. Since this is giving the substituent the parent chain, since numbering from here will give the substituent the lowest number, we are going to take this route. So we are not using this, we are not using this, we are not using this. What then is the name of this alkane? The substituent is called methyl. And the methyl group is on what? Carbon 2. Therefore, the name will be what? Let me use the black. Alright, the name will be 2-methyl. Why is it 2-methyl? Listen, because the substituent is on what? Carbon 2. And then, what's the longest thing? 4 carbons, which is what? Butane. Wow. Very simple. So, the name of this hydrocarbon is 2-methyl what? Butane. 2-methyl what? Butane. Very simple. You don't need to memorize all these rules. But when you keep on learning how to name new structures, how to draw structures, you will end up knowing all these rules in your head without memorizing them. Okay, we can't assume we've known everything with just a single structure. So let's move on to the next structure. How? How do we then name this structure? Please don't be confused. Like we talked about the skeletal or the line angle structure. This is a typical example of the line angle structure. And remember what I told you. I said each of the points here represents what? Carbon. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and this is also another part carbon. This is a typical line angle structure. Let's do this. Let me show you something. Let us convert this line angle structure to our condensed structure and see how it will look like. I told you carbon is here, right? And the beginning of any alkane, I told you 3 hydrogen must be attached to it. So this probably will be CH what? 3. That is for this. And then the rest will be CH2, apart from the last one. This will be what? CH2. We are done with this. Let's go to this. This will be what? CH. No longer CH2, because a methyl group is attached to it. This is the CH. This is another CH3. CH3. Then let's move to the next one. CH2. And then the last carbon should have 3 hydrogen. CH what? 3. Wow. So whenever you see a skeletal structure like this, don't be afraid. It's the same thing. This and this, they are the same. So how do we name this compound? Following our rules outlined here on the board. Okay. Identify the longest chain. That should always come to our mind. Identify what? The longest chain. Whenever you are naming any organic compound, be it alkane, be it alkene, be it alkanes, anyone, the first thing that should come to your mind is what? Identifying what? The longest chain. So let's do that. We have 1. Okay, I think we should use our red marker. We should use our red marker. This is, each of the points here signifies 1 carbon. Hope you are following. Carbon number 1. Carbon number what? 2. Carbon number what? 3. Carbon number what? 4. And carbon number what? 5. 5 what? Carbon. 5 carbon. What should come into your mind? Correct. Pentane. That's pentane. If you name it, number it this way: 1, 2, 3, 4, 5. The same word, pentane. What other way can we number this? Yeah, from on there. You can also number it from here. We have 1, 2, 3, 4. 1, 2, 3, 4. But do you know what? We can't actually use this particular method. We can't use this numbering here. Why? It will give what? A less number compared to the first one we got. So we are not using this. We are not using this. This one is just 4, while this one is 5. We use the one that has the highest number. The next thing would be the substituent. the substituent here, if you count it this way, the substituent will be on carbon 3. If you take it this way, the substituent will also be on what? Carbon 3. So either this way or this way, it will be the same thing, it will be correct. So what then? Yeah, what then would be the name of this hydrocarbon? Yes, of course, it's correct. It will be what? 3 what? Methyl, and then 5 carbon is what? Pentane. Yeah, correct. 3 methyl what? Pentane. Very simple. So, organic chemistry or naming organic compounds, I don't think there's anything difficult there to name organic compound. It's just for you to calm down your mind, know the rules, follow the rules one after the other, and then you're good to go. I know someone is afraid of this structure. That's nothing about you guys. You easily fear because of structures you feel they are complicated. They are not complicated. It's just your mindset. If we know these rules now, we'll get it. Okay, let's take it. Let me use the red marker to number it. So who can tell me the first rule? It's on the board, right? Identify the longest what? Chain. Let's see this. This is 1. This is 2. This is 3. This is 4. This is 5. This is 6. And this is 7. Wow. Is there any other way we can number this? Okay. On the one under, yes, we can also number it this way. Oh, let's use our black marker in the second number. Yeah, let's use, we'll number it that way. Use our black marker. 1, 2, 3, 4, 5, 6, 7. So it's the same thing. It's what? 7. So either numbering it this way or this way still gives the same thing. Let's go back to our rules then. It said substituents are listed in substituents are listed in alphabetical order. Do you know why I'm on this now? Because there are 2 substituents here, unlike the first and the second compound that we named. This one has 2 what? Substituents. So no matter what, we are going to make sure that these substituents are listed in alphabetical order. Alright. Prefixes like di, tri, tetra are not included. We don't include those ones. So when it comes to alphabetical order, choose the parent chain with a greater number of substituents. Okay, let's go back to this number 6. We're having 1, 2, 3, 4, 5, 6, 7. This will be, if we are taking this way, are you following? Yes. If we are taking this way, if we are taking this numbering now, this will be the substituent and this will be what? The substituent. So if we are taking from here, we have how many substituents? 2. Alright. Yeah. Okay, you're following. That's good. Nice one. Okay. How about taking it this way? This will be substituents, this substituent, and this will be another substituent. 2 substituents also. Alright. Okay. So what do we do then? Since we have 2 substituents. Okay. We are going to consider rule 2. Give each substituent on the parent chain a name and a number. Okay, not that one. We'll consider rule 3. Number the parent chain in the direction that gives the substituent the lowest number. So if we are numbering it this way, this particular carbon will be on carbon 3. While this particular substituents will be on carbon 3. While this one, 1, 2, 3, 4, 5 on carbon what? 5. 3 plus 5, 8. If you are numbering this way, 1, 2, 3, carbon 3, and what? 5. The same thing. Wow. The same thing. So Taking it this way or this way would be what? Would be correct. What then would be the name of this what? Of this alkane, this structure here. Alright, let me get this one. And there is. We are taking this way. Yes. So let me remove this one. Because in either way you get it. Okay. Let me keep this here. Okay. Okay, don't worry, we'll name it together. Alright. We have this now. Look at this. Yes, your eyes should be on this. This is the point. This is carbon. This is another carbon. And remember we said 2 carbon, alkanes, any alkane that has 2 carbon is what? Ethyl. So ethyl, and this is substituent. It means 1 hydrogen has been what? Has been removed. Thank you. So removal of 1 hydrogen makes it an alkyl group. This is no longer ethyl, but what? Ethyl. This is ethyl. Why this one? Just 1 carbon is what? Methyl. This is what? Methyl. E comes before what? M. So how do we name this now? The name would be what? 1, 2, 3. Okay, let's take it. Name will be what? 3 ethyl. And then 5 methyl. This will be small letter now, no longer big letter. And what? The elongation is what? FT. There is one thing you have to consider here. Before any letter, the space between a number and a letter, there should be hyphen there. Never ever make that mistake. Make sure you put your hyphen. So the name will be 3 ethyl, 5 methyl, FT. It is 3, the 3 ethyl is coming before the methyl, not because of this membrane, but because E comes before what? M. Wow, you're done with that. Okay, we have 2 more structures. We keep on learning this structure, but let's consider these 2. The rest will give us classwork and see those that will get it and those that will fail. But I don't think anybody will fail. Oh, no. You're all familiar, right? That's good. Okay, let's name this. Should we name this together or we are naming it together? Okay, it's example. Alright, someone said I should name everything because this example is for the tutor. Alright, let me name it. But we'll do it together. Identify the what? The longest chain. Let's identify. Oh, let's count from here. 1, 2, 3, 4, 5, 6. 6 is for what? 6 is for what? Yeah, hexane. 6 is for hexane. We have how many substituents here? 3. But they're all the same thing. Yes, they're all the same. Methyl. Let's take it fast now because we are getting it. This is methyl. This is what? Methyl. But there's something spectacular about this particular structure. We have 2 methyl on carbon 2. But before, let's try and number it this way. 1, 2, 3, 4, 5, 6. Okay, the same thing. Yeah, the same thing. 6. Remember, we have what we call di. Di is for 2, tri is for 3, tetra is for what? 4. So we're having 2 methyl here on carbon 2. The name will be what? 2. The space between, remember, I said the space between number and letter you put hyphen. While between 2 numbers you put what? A comma. It will be 2, 2. It is 2, 2 because the 2 methyl group are on carbon what? 2. 2, 2, you put your hyphen. Alright? You put your di versus 2. Di methyl. How you following? Oh, we've forgotten the other methyl here. Are you not seeing that we have another methyl on carbon 4? Yeah. We have another methyl on what? On carbon 4. So it will be tri. So we have 2, 2, 4, tri methyl. The longest chain is what? Ethyl. Let's explain this. This 2 is for this other 2 is for this, while this 4 is for this. And then they are all methyl group, 3 methyl group, tri methyl. The longest chain is what? Hexane. Okay, let's name this 2. This is another simple one. Okay, let's see it. I think there should be 3 here. All these structures are very simple. Are we naming this together? Okay, let's do justice to it by naming this together. Okay, let's number it this way. 1, 2, 3, 4, 5, and 6. You can still number it this way. 1, 2, 3, 4, 5, and 6. Which way will be correct? If we number it this way, the first carbon, if you are numbering this way, I think I should use the red so we don't get confused. How I depend about this? Let's consider this one very well. Since we can number in both directions, let's look for the best number, the one that will give the parent chain, that the number, they say number the parent chain in the direction that gives the substituent the lowest what number. So let's keep it like this. Let's say 1, 2, 3, 4, 5, and 6. If we are numbering this way, our first substituent here would be carbon 2. Our second substituent will be on what? Carbon 4. 2 plus 4 is what? 6. That is when we are numbering this way. When we are numbering from the right hand side, yeah, from the right hand side. Okay. How about numbering from the left hand side? Our first carbon will be on what? Our first substituent, rather, yeah, first substituent will be on carbon 3. While our second substituent will be on what? We have 3 on carbon 5. 3 plus 5 gives what? 8. You see, that is why it's very important to know the rules. Because someone can come up and maybe number it in a particular direction and give that structure a name. At the end of the day, you'll be like, what I saw there is not my results. I did very well. Because you didn't take your time to number it from the 2 directions or from all the possible directions. If we number it this way, the substituent, if we number it this way, adding the number of the substituent together, we'll get what? 6. While if we number it this way, we'll get what? 8. So according to this rule, number the parent chain in the direction that gives the substituent the lowest number. Between 6 and 8, which of them is the lowest number? Yes, 6. 6 is the lowest number here. Therefore, we take it this way. What then will be the name of this compound? I'm going to use the red marker since the red got it. It will be 2,4-dimethyl hexane. Wow, that's very good. So you now see that naming alkanes or naming organic compounds is very simple. All what you need to do is follow the rules. Take it one after the other. Never ever forget these rules. Don't be in a hurry while naming organic compounds. Make sure that your numbering comes in all the possible directions before you choose the right one. I think I'll give you one more structure. Yes, I'll give you assignment. Yes, I'll give you assignment, and then that assignment you learn how to draw the structure. You must not get it. You might fail, you might also pass, but keep on practicing. So at the end of this class, I'll give you assignments. In our next class, we'll be looking at what we call the cycloalkanes. We'll look at the cycloalkane. But for today's class, know this. Know that saturated hydrocarbons are hydrocarbons with what? Carbon-carbon single bond. Unsaturated, they have either carbon-carbon double bond, triple bond, and so on. Know that alkanes, they are saturated hydrocarbon with what? Carbon-carbon single bond. Do not also forget about the word the alkyl group, a group that is gotten from the alkane group by removing what? One hydrogen. Do not forget about your rules. I think that's all for this. In our next class, we'll continue from here. Thank you.